students, today's agenda is to check homework. We'll be learning about area to volume proportions, and you will be able to do 11.12. Today, students will be able to use area to volume proportions. But before we start, these are the steps that we need to take. If you have seen the previous two lessons related to proportions, but only between the sides of a figure to the surface area or from the sides to the volume, then this step must be familiar to you. These steps take an extra step because we always have to go back to length. And if you haven't seen those videos, it'll make more sense when you start seeing the examples. So before we even start, if you can take note of this, pause the video, write them down, or as I explain them. But again, once we start with the examples, it will make more sense. Have this next to you. I'm going to be putting it in and out so you can follow. Number 1 says, find the volume of the second cube. Now in here, if the surface area is the same for both figures, then if the volume of the first figure is 64 cubic meters, then when they have the same measurement, either in surface area or length or whatever, then we're going to have the same surface area and the same volume for both shapes. So X is going to be 64 cubic meters. So that's easy. But what about if we have something like this? It says here the surface area is 4 times as much. If we multiply 96 times 4, we get 384. Here, if they didn't tell us this information, how do we know? The first step is to divide the big measurement by the small one. In here, we cannot divide these ones because we don't have one of those measurements, but we have these two measurements. That's the one that we divide. Now, the big shape is this number, and we can look at the shape or at the numbers. Okay, so 384 divided by 96 is equals to 4. Now that number, we need to understand that that's a ratio between. So it's the ratio between the surface area ratio or comparison. So there is 1 square meter in here for every 4 square meters in here. That's what it means. The next step, it says take either the square root or the cubic root. If it's surface areas, and let's say I'm going to put the surface area ratio in here, or the volume ratio in here. Okay, so if what we're dividing is the volume, we will get the cubic root. But since it's surface area ratio, we're going to get the square root. What is the square root of 4? Most of you already know that it's 2. So you get the second function. Then here is the square root down there. That's why we're doing the second function. And then we put 4 equals. So it's 2. That gives us the length. Okay, by taking the surface area ratio, we're getting a length comparison or ratio. So if we were comparing these sides and we don't know the measurements compared to these sides, what that means is that by taking the square root, I'm going to get a length ratio. Length ratio is equals to 2. Okay, so now we're comparing the two sides, but that's not what we're looking for. What we're looking for is volume, cubic. Now that I have the length ratio, I go and see which one am I looking for? Am I looking for the surface area or the volume? What I'm missing is the volume, so I'm going to raise it to the third power. And again, by doing that, what I'm doing to the length ratio, I'm making it into a volume ratio. Not looking for the volume yet, but looking for the comparison between the two volumes. And so by raising that to the third power, 2 to the third power means 2 times 2 times 2. So it's going to be 2 cubed, which is the same as 8. 2 times 2 is 4, times 2 is 8. This is the number or the ratio between these two. Now, if I have the small measurement, then I'm going to multiply times whatever I got in here. But if I have the big one, then I'm going to divide. Since I have the smaller one, I cannot divide it. Otherwise, I'm going to get a amount. What I need to do is multiply. Okay, so 64 times 8, because that's the comparison, that's the ratio between the volumes. And so 64, which is what they gave us, the volume of the smaller one, times the volume ratio, which is 8, gives us 512. So X is equals to 512 cubic meters. Okay, and so that's how we find the volume for that bigger figure. So notice how the surface area is 4 times bigger, or 4 times as much, but the volume is 8 times as much. And so let's put that volume ratio. Okay, I think we're going to be able to go a little faster now that we understand that step number 1, divide the big by the small of what we have. In this case, it's 512 divided by 64. And guess what? 512 divided by 64 is 8. Because sometimes, why am I doing this? It's because sometimes I'm not going to be missing the volume, but rather one of the surfaces. And sometimes I'm going to be missing the bigger shape measurement, sometimes the smaller shape measurement. Okay, so when I divided big by small, I got 8. So that's the volume ratio. When it's volume, I needed to go to length. We cannot go directly to the surface area this way. So what are we going to do? Let's look at step 2. When we have the volume ratio, we're going to get the cubic root. Cubic root of 8. Well, what number multiplied by itself 3 times is 8? Oh, it's 2, because 2 times 2 times 2 is 8. So the length ratio will be 2. Now in your calculator, and I know different calculators have different, let me see if I have the cubic in here. No. So when I have these calculators, this is what I'm going to do. If you see in there, it has an X. So it's the root, but with an X in here. So what you're going to do is put the 3 first. Then you're going to put second and that button right there. So if you notice, that gives the value of X. And then you put 8 and equal. If you notice, that's the 2 right there. Let me show you again so you don't have to rewind. So first the cube, which is a 3. Then second function. And then that right there with the X. The root with the X gives us that. And then put the 8 equal. And you get 2. After that, that gives us the length. Okay, always the length. What are we looking for? Surface. Look at what we're missing. We're looking for surface, so we're going to raise to the second power. So 2 to the second power. 2 to the second power will give us the surface area ratio, which is 2 squared, right? It says if we're looking for surface area, then raise to the second power to get surface area. And 2 squared is 2 times 2, which is 4. Finally, if we have the small one, we multiply to get the big one. But if we had, let's say it would be, we have the big one and we're trying to get the small one, then we divide. From little to big, multiply. From big to small, we divide. In this case, we're going to multiply to get the bigger one. And so 96 times 4. Okay, so 96 times 4, which is the surface area ratio, not the length, not the volume. We need to have the surface area ratio. And so X is equals to 384 squared meters. Okay, be careful with the unit of measurement. Volume is always cubed and area or surface area is always squared. If you notice, it was the same one, except that we were missing the volume in here, but in here we were given both volumes and we were missing one of the surface areas. Okay, for number 4, it says find the missing surface area. So divide big by small. We cannot divide surface areas because we're missing one of them, so we are going to divide the volumes. 19,683. 19,683 divided by 729. And that's my ratio, okay? The volume ratio or comparison is 27. The next step is, so if I found the volume ratio, then to get length, I'm going to get the cubic root. So in these modular calculators, it's the other way around. First, you press the number, second function, and then if you notice the cubic root is right there. You don't need to put the 3. It's already in there. And it gives it to you without pressing equal. In here, you press the 3, second function, the root with the x, 27, equal. And you get 3. So for this one is 3, second function. It has that line behind is the root with the x. Put the number and then equal. Okay, but for the tiny one is first 27, second function, and the square root, but behind it is the cubic root. And you don't need to press equal. So when we get the cubic root of 27, we get a length. Remember, it always takes us to length. And the length ratio is 3, right there. After we have the length, we raise to the second power because we're looking for a surface area. That's what we're missing. Okay, so raise to the second power, and 3 times 3 is 9. So for my surface area ratio, it's 9. Finally, here it's a little bit different. Which one are we missing? Which one do we have? It says we have the bigger. So it says if you have the big measurement, then what are we going to do? We're going to divide that big number divided by the number that we found, which is 9. So in here, to go from here to here, we're going to divide this surface area divided by 9, and that'll give us the value of x. So 4,374 divided by 9 gives us 486. And don't forget the unit of measurement. So it's 486 squared meters. And here it just says solve for x, but what we're finding is another surface area. Okay, again, the first step is to divide big by small. So 100 divided by 30, that's 3.33333333 forever. Then that's volume ratio. So if we have the volume, what we need is the cubic root, okay? So we press 3, second function, that cubic root, with the x, I'm sorry. Then put 3.33333333 and press equal. It's 1.493. And you can put more if you want. 1.4938. The more you put, the closer to the answer is, but it's just rounded, okay? We're looking for surface area, so we need to raise that to the second power. So in here, all you have to do is square it. Oh, so that's the answer. This is the x to the second power is just squaring it. Answer squared equals 2.2314. So the surface area ratio is 2.2314. And finally, we have to decide if the shapes are almost the same and we can't really figure out. We can look at this measurement and say, oh, this is bigger. That means that I have the big surface area. And if we have the big one, if you have the big measurement, then we're going to divide the big measurement divided by whatever we found, which is the answer. Okay, so let's divide 27 divided by 2.2314, and it gives us that this measurement is 12.10 square meters. Again, because it's right in the middle, I'm just going to put x is equals to 12.10 square meters. And that's my answer. Okay, again, the first step is to divide the big by the small one. And in here, what we have is two surface areas. So and I noticed that this is the bigger one. They're not, like, they switched. So 486 divided by 54 gives me 9. And that's the surface area ratio, or the comparison between the two ratios. Because we want to get it to length, well, to get to length, and I have a surface area ratio, I'm going to take the square root. Okay, square root of 9. Second function, let me clear that. So second function, the square root of 9 equals, and I know that some of you already know, you don't need to do it, but that's fine. So the length ratio is 3. So if the surface area, or the comparison between the two surface areas, is 9, that means that the length, this is 3 times as long as this one, okay? 3 times the length. That's what it means in here. But now we're looking for the cubic ratio, or the volume ratio. And to find the volume ratio, we need to raise to the third power, because volume is cubic. So we raise this to the third power. So volume ratio is 3 cubed, which is 3 times 3 is 9 times 3 is 27. Now, you can also do it like this, 3. This is to raise to the any power. So raise to the, and in this case is third power, equals 27. Okay, this is power button in this calculator. Now, what are we missing? Well, what we're missing, look at the shapes, look at the measurements. We're missing a volume, but we're missing the volume of the smaller one. So it says that if you have the big measurement, then we're going to divide. So be careful with this last step, because if what you have is the small one, we're going to multiply whatever you got in here times the measurement of the small one. But if we have the big one, then you're going to divide the big measurement that we have by the number that we found. So in here, order matters. We first have to put the measurement of the figure or shape. Okay, so since we're going to make it smaller, we're going to divide. And so what are we going to divide? The big number divided by the volume ratio. Okay, so 729 divided by 27, and that gives us 27. So the volume of this tiny shape is 27 cubic centimeters. So x equals 27 cubic centimeters. With this, we end our lesson. If you can please support our channel by giving us a thumbs up. You can subscribe around here. This is another video related to math. Here you can find the link to the entire unit. Now you're able to do 11.12 and have fun.